can you solve these 6 calculus problems? At time of recording, the A-Level Maths Paper 1 is tomorrow, and this will be perfect practice for that exam. Or maybe you're looking at this a bit later in the week, in which case this is still perfect practice for Paper 2. For this week, I've scaled back the difficulty a little bit in comparison to last week. However, there is still some challenge here, and I'm mostly trying to make sure I'm not overwhelming you too much with exams on the horizon, but still also going through some of the fundamental skills that you will need for the exam. So, pause the video, have a go at the problems, and the solutions will follow shortly. In this first question, we need to find the range of values of x for which the function, as you can see there, is convex. So I want to do a question that revolved around convex or concave, as I haven't done one of those yet. And what we need to know is when we differentiate and find our first derivative, that is finding our gradient function. What the second derivative does is it finds the rate of change of the gradient. If a function is convex, then the second derivative is positive. It means the value of the gradient is increasing. If a function is concave, it means the value of the gradient is decreasing. So in this question, I'm going to find the range of values for x for where it's convex. So I need to find the second derivative and find where that second derivative is going to be positive. So we differentiate the first time. So we just differentiate. All of this is just as simple as multiply by the power, take one of the power for each of these terms. So x power 4, 4x cubed. Minus 5x cubed becomes minus 15x squared. And then we'll have 18x when we differentiate the 9x squared. Minus 9x is minus 9 when we differentiate it. And the minus 2, that will just be 0. So that's our first derivative, but we need to differentiate that result to find our second derivative. So differentiate 4x cubed, we get 12x squared. Differentiate minus 15x squared, we get minus 30x. And differentiate the 18x to get 18. When we differentiate the minus 9, that will just be 0. Now, we're looking at where this is convex. So it's convex where the second derivative is greater than 0. One little note I will make is in the Pearson textbook it will say greater than or equal to 0 for convex or less than or equal to 0 for concave. We checked this with the exam boards and they said it doesn't actually matter if you use greater than or equal to or greater than as long as you are consistent with it. Okay, so you use just greater than or less than signs throughout, or you use greater than or equal to or less than or equal to signs throughout. So I just want to clarify that point before I went further. So if a value of x satisfies that inequality there, then the function is convex. So what I'm solving here is a quadratic inequality, something that you would have done in year 12 or first year of A-Level Maths. So to solve this quadratic inequality, the first thing I'm going to do is just divide both sides by 6 here. Oh, not 3. Sorry, not 6. It's going to be 3. Okay, so just going to simplify a little bit to help me. So I've got this quadratic inequality to solve. So the first thing I'm going to do is find what I call the critical values, which is where I'm going to set this quadratic to 0. Okay, I'm going to find the roots of this, and these roots will help me find the range of values of x for which it's concave. So we just factorize this. Make sure that, if a question does talk about showing your working in particular, makes a big note of that at the start of the question. Make sure that you are showing the factorizing, how you use the quadratic formula or completing the square. Because they do like these questions. They do know that you've got these calculators. So I found my critical values there of 1 and 3 over 2. Okay, so that's where the quadratic would equal 0. I want to find where this quadratic is positive. So if when x is 1 and x is 3 over 2, the quadratic equals 0, I can see from just a little sketch here, Okay, it's a positive quadratic, so it's going to have that U shape. I can see that if x is less than 1, or if x is greater than 3 over 2, then you've got solutions there. Okay, so that would just simply be my solution, that if x is less than 1, or if x is greater than 3 over 2, then the function is convex, i.e. it means that for any of those values of x, the rate of change of the gradient is increasing. Right then, on to question 2. We are going to find the equation of the normal to the curve when x is 1, and we're going to leave our answer in the form ax plus by plus c equals 0, where a, b, and c are integers. So this is quite a common thing they'll ask you to do in the exam. Find the equation of a tangent, or in this case, find the equation of the normal. So when we've got this here, when we're trying to find the equation of a line, we need to know the gradient and we need to know a point on the line. Okay. At the moment, all we know is the x-coordinate. So we're going to need to find the y-coordinate. And we're also going to need to find the gradient for this line. Okay, so if we're thinking about gradient, and you probably guessed this is a calculus video, we are going to need to do some differentiation. So what I'm going to need to do is I'm going to need to differentiate 1 over 2x cubed plus 1. So I'm just going to start off by rewriting that as y equals 2x cubed plus 1. And I'm going to do that to the power of minus 1. And as we have used so many times already in these 7 weeks, we're going to use the chain rule here. Who could have seen that coming? So I'm just going to let u be the bit inside that bracket. So y is just u to the minus 1, where that u is 2x cubed plus 1. So we need to find dy by du, which would be minus u to the power of minus 2. And you'll need to find du by dx, which is just going to be 6x squared. I want to find dy by dx, so multiply your minus u to the minus 2 by that 6x squared, and put back in the fact that u is 2x cubed, and we'll get minus 6x squared times 2x cubed plus 1 to the power of minus 2. So that's our gradient function in general. What we're going to want to do is find out what the gradient is when x equals 1. So we just sub in x equals 1 into this. So minus 6 times 1 squared times 2 times 1 cubed plus 1 all to the power of minus 2. When I do that, I get minus 2 over 3. So that's the gradient of the curve when x is 1. But that would be the gradient of the tangent at that point. I'm asked to find the gradient of the normal. Okay, so if the gradient of the tangent was minus 2 over 3, the gradient of the normal is the negative reciprocal of this. So that minus 2 over 3, we're going to change the sign of it, and we're going to flip, so to speak, okay, technical words, reciprocal, for that to get your gradient of your normal as 3 over 2. So I've got a gradient for my line. I know the x-coordinate. I just need to also know what the y-coordinate is going to be. So when x is 1, I just sub that into y equals 1 over 2x cubed plus 1. So 1 over 2 times 1 cubed plus 1. So when x is 1, I sub that into my y, and I get a third when I do that. So I know that 1/3 is the point, is a point on the line. I know the gradient of this normal is going to be 3 over 2. So then I can just sub it into equation of the line. Up to you whether you use y equals mx plus c. I'm going to use y minus y1, the y minus y1 form, but you can do it either way you like. So y minus 1/3 is equal to 3 over 2 times x minus 1. And now I just need to start getting it in that form ax plus by plus c equals 0. What I'm going to do is I'm going to times both sides by 6 here to start getting rid of these fractions. So times the left-hand side by 6, and times the right-hand side by 6. 3/2 times 6 is going to be 9. Then you can just expand that bracket, and then just get everything to one side. So I'm going to take 6y from both sides. I'm going to add 2 to both sides. And then we've got our solution. Right, on to question 3 then. We've got to find the stationary points of this curve here, okay? We're told that minus 2 pi, x is between minus 2 pi over 9 and positive 2 pi over 9, okay? Trust me, that will make our problem a lot shorter when we get to that section of it. So if we're finding stationary points occur where the gradient equals 0. Such an important fact to learn. I'm almost certain something about stationary points will come up in at least one of the 2 papers. So what we're going to need to do first is differentiate that. What we have though is a function of x times a function of x. So I'm going to let the first function, we'll call that u. So that e to the 6x, I'm going to call that u. And v is going to be my second function, the cos squared 9x. So for the product rule, I'm going to need to differentiate e to the 6x. So that will just be 6e to the 6x. You just need to times by that coefficient of x. And we're going to differentiate cos squared 9x just at the top here. I'm just going to show you how I would do that with the chain rule. So you're squaring cos 9x. So I'm going to say v is w squared, where w is cos 9x, and dv by dw is 2w, would work out dw by dx. So differentiate cos 9x, that'd be minus 9 sine 9x. So timesing those two things together, timesing the dv by dw and the dw by dx together, you can get minus 18 sine 9x cos 9x. Okay, I'm just subbing in that w back in as cos 9x. So dv by dx is minus 18 sine 9x cos 9x. So now I need to find what dy by dx is. So we're going to times u and dv by dx together. I'm using the product rule, remember here. Let's get minus 18 e to the 6x sine 9x cos 9x. And I multiply that by, I add on the product of du by dx and v together. So timesing du by dx and v together, I get 6e to the 6x cos squared 9x. Okay, so I'm going to set that equal to 0 now, because stationary points occur where the gradient is 0. That is such an important definition to remember. Okay, stationary points occur where the gradient is 0, so where dy by dx is 0. So now what we're going to do is solve this equation, which looks horrendous at the moment. But trust me, it's going to look a lot simpler pretty shortly. So first thing I'll do is just look at the fact that I can just divide both sides by e to the 6x. And that will be fine, because I wouldn't ever be dividing by 0 here, because e to the 6x can never equal 0. So I can divide both sides by e to the 6x. I can also divide both sides by 6 to make it easier. And I can also divide both sides by cos 9x as well. Okay, and you won't be losing solutions there because of the sine 9x as well. It would never work out that you'd lose a solution there. So divide both sides by 6e to the 6x cos 9x. Let's have a look at what that looks like. 18 divided by 6 is 3. The cos 9x is gone. So we're just left with that for the first term. And for the second term here, we're dividing by 6, we're dividing by e to the 6x, and we're dividing by cos 9x. So that'll just leave us with a cos 9x. And that's going to equal 0. I can then add 3 sine 9x to both sides and divide both sides by sine 9x. So I end up with cot 9x equals 3, which means that tan 9x would be 1 over 3. Okay, I want to convert it into a problem either with sine, cos, or tan, because those are the functions that I can access on the calculator. Okay, so that what started as a pretty horrendous equation to solve has simply just now ended up being solve tan 9x equals a third. So before I do that though, I'm just going to consider what my interval here is. So I was told that x is between minus 2 pi over 9 and 2 pi over 9. So I haven't got x, I've got 9x. So what I want to do is with this interval is times all parts of it by 9. So I know that when I'm solving, I know that 9x needs to be between minus 2 pi and positive 2 pi. So when I do arctan, or inverse tan, of a third on my calculator, I'm not actually finding the solutions for x. I'm going to find the solutions for 9x. Okay, and what also can help is just doing a little sketch just to see that I've got all the solutions that I need. So if I just draw what tan is going to look like between minus 2 pi and pi, I can just check that I'm going to get all the solutions that I need. So there should be, that's minus 2 pi, that's 2 pi. So there should be 4 solutions that I need to find for this. Okay. So for 9x, so when I do arctan of a third on my calculator, the first solution I get is 0.32175. I'm going to go to 5 significant figures here because I'm going to end up dividing by 9. I just want to make sure that I get my answers at the end correct to 3 significant figures. So I'm going to go to quite a high level of accuracy here. Okay, so that would be this solution here. Okay, well, I've got 3 other solutions to find. Now, the great thing about tan is to find the next solution up, all you need to do is just simply add pi onto it. So that's the first solution. Remember, these aren't solutions for x, these are solutions for 9x. So to get the next solution, I'm just going to add pi to that. That would be 3.4633. So now I've got the 2 positive solutions. I need to find these 2 negative ones now. What I can do is go back to that principal solution of 0.32175 that I found, take pi away from it. Tan should be our favourite because all we have to do is simply add and take away pi from it. And if you take away pi from that solution, that's what we get. To find x though, because we want to solve this for x, we just then need to simply divide all of these solutions by 9. As I'm writing these out, one thing I didn't mention earlier was, of course, when we're doing calculus, we always need to be in radians. Okay, so these solutions are all in radians. Okay, we don't use degrees in calculus, and it's all to do with how we actually prove the definition of how we differentiate sine and cos. Okay, we have to use radians for that, using the small angle approximations, which relies on radians. So just make sure you're always in radians when you're doing calculus. So I divide them all by 9, and I've just given them all there to 3 significant figures. Just want to check that those solutions do actually lie within that interval of minus 2 pi over 9 and 2 pi over 9, which they should do. And those are solutions there. Right, now we're going to look at the integration questions, and we're going to start it off with some integration by parts. It's not really any simplifying that you can do at this stage, so we're going to need to use parts here to integrate this. Now remember, with parts, you get this in the formula book, so please refer to your formula books. And when I'm doing parts here, it's not u and v that I call each function here, like I would with product rule or quotient rule, for example, but it's going to be u and dv by dx. I'm going to call the first function the u, so u is going to be x, and I'm going to say dv by dx is going to be sine x. The reason why I want to do that is because when I work out du by dx, I'm going to get a 1 there, which is going to be pretty easy to work with. And dv by dx is sine x. Well, I can easily integrate that. to get minus cos x. Now, as I mentioned, the integration by parts formula is in your formula book, so please refer to that. So what I have to do first is do u times v, so that would be minus x times cos x. And then what you're going to do is take away the integral of du by dx times v. So that's 1 times minus cos x, which would be minus cos x. What I'm going to do though is just write that as positive cos and then just make it a plus on the outside there. So I need to keep going till everything has been integrated, all those integration signs have gone. So I don't need to do anything with the minus x cos x, but I'm going to need to integrate the cos x there. So integrate cos, we get sine. Remember, this is just going to be a positive sign. And then we just have our plus c there at the end. So just a nice quick reminder of some integration by parts there. Looking at question number 5, you might sometimes see problems like this in the exam. They might look scary and completely different, but in essence, this is still just an integration problem. So you might see it as a sum like this. All it means is just integrate this between e and e to the power of 3. So just wanted to, before your exams, let you see another one like this, just to remind you that if you see the sigma and the limit, you just need to integrate here. So let's just rewrite the problem. So I'm going to put the integration symbol here, and I've got a lower limit of e and upper limit of e to the power of 3, and I'm integrating the following. Okay, now before I go ahead and actually integrate this, I need to ask myself that question, can I simplify it? And I definitely can here. I can just divide both terms by the 5x. So 8 divided by 5x, well, I'll just leave it as 8 over 5x there. And minus 6x divided by minus 5x would just be minus 6 over 5. Okay, so now I'm just going to integrate term by term. Now remember, when you integrate 1 over x, that becomes natural log of x. So because I'm timesing that by 8/5, this will be 8/5 of natural log of x. I need to put the modulus there. It won't really affect this question, but we should have it anyway, just for consistency. And then when you integrate 6 over 5, we just integrate a constant, we just put an x on it. Because I'm doing definite integration, I'm going to put the result there in square brackets. And then what we're going to do next is actually plug in those limits of e to the power of 3 and e. So when I substitute in e to the power of 3, so I put that upper limit in first, it will give me the following. Okay, so that's the result of putting in the upper limit. I'm then going to sub in my lower limit of e, so it'll be 8/5 natural log of e minus 6/5 e. Right, and then we're just going to simplify. So natural log of e to the 3, that's just going to be 3, so 8/5 of 3, that'll be 24 over 5. Can't really do anything about the 6/5 of e cubed, we're just going to leave that exact. Natural log of e is just 1, so that would just be taken away at 8 over 5, and then minus 6/5 e be the following, and then I can just do 24 over 5, take away 8 over 5 to get 16 over 5 minus 6 over 5e cubed. I'm just going to leave it all exact, as a lot of questions will ask you to do. I'm just going to leave it there, all in terms of e. And then we get to our final question. Okay, now have a go at it. But what I'm going to do is I'm just going to give you a hint first. So I'll give you the hint, and then maybe after the hint, you might then want to have another try at this. So the hint I'm going to give you is that when I differentiate 9 plus 6x minus 18x squared, which as you notice, that's the bit inside the second bracket. When I differentiate that what's inside that second bracket, I get minus 36x plus 6. So if you want to pause it here and have another go at it, try and see if you can now work it by using that hint. Right, so what you may or may not have noticed is that minus 36x plus 6 is actually a multiple of 6x minus 1, okay, what I get in that first bracket. So what that would lead me to think is, well, what happens if I try a result of what's in that second bracket to a higher power? Because I know that using the chain rule, when you differentiate inside that bracket, you're getting a multiple of that 6x minus 1. So let's try as an answer 9 plus 6x minus 18x squared to the power of 6. And let's see what happens when I differentiate that. Let's see if I do actually get the result that I started out with. So let's check that via the chain rule. So I'm going to let u be what's in that bracket. And we're going to do dy by du, which is 6u to the power of 5. Du by dx is going to be 6 minus 36x. Dy by dx then would be, times that all together, I get 6 lots of 6 times 36x times u to the power of 5, which is 9 plus 6x minus 18x squared to the power of 5. And then what we can notice here is that 6 minus 36x, if you take out a factor of minus 6, so do 6 times minus 6, I'm left with 6x minus 1 in the bracket there. So when I try 9 plus 6x minus 18x squared to the power of 6, I almost get the answer, but there's an unwanted minus 36 there. So because I don't have that minus 36 in what I'm trying to integrate, when I leave my answer, I'm going to put a minus 1 over 36 in front of the 9 plus 6x minus 18x squared to the power of 6. Obviously putting that plus c there as well. And if you differentiate that, you can check that you do get that result. So that will do it for this week. Let me know how you got on. Next week I'm going to look at what actually came up on paper 1 that's due to come out tomorrow at time of recording. And I'll try and tailor next week's problems with that in mind. And also we'll look at a special applied calculus 1 for the following week as well. But let me know if there's anything particular that you want to go through, if you've got any questions. And happy calculus, everyone.